What is a botnet? The term bot is short for robot. A bot is a piece of software with a tiny bit of intelligence that runs on a computer and carries out commands sent from another computer. Bots are not inherently evil. Without bots, Google wouldn't have search results to report. But like any tool, bots can be used for good or evil. To survey how bots are used for evil, cue the magic whiteboard. An attacker, called the bot master or bot herder, creates a malicious Trojan called a bot client. Over the internet, he infects at least one clueless victim. Once installed, the bot client can take over the victim's computer at any time, but usually it does nothing visible. Instead, the bot herder programs the bot client to report to the command and control center and say, "I've infected someone, over here." Most bot herders install an internet relay chat server to act as their command center. When a bot connects to the command center, the bot herder updates it with new attacks and instructions. Then the bot client scans other computers, trying to install more bot clients, which also call back to the command center. So when we mention bots, we're referring to the collection of hijacked computers, sometimes also called zombies, all controlled by the bot herder when he logs into his command center. That's the botnet concept, but so far all you've seen is me and some graphics. To see a botnet built from scratch, stick around. The first step in building a botnet is creating a bot client, the Trojan that installs the bot code on a victim's PC. To create this bot client, you need source code. Writing bot source code takes skill and time, so most bot herders buy code or trade for it on underground forums. That's where I found source code for hundreds of botnet variants, many used in the wild today. Let's see how a typical bot herder builds his network. We'll call this guy Spike. The tool Spike would choose is RxBot, a popular Win32 bot programmed in C++. To convert source code into something a computer can interpret, Spike needs a compiler. To view his bot source code, he opens it in a popular compiler called Microsoft Visual Studio 6. This video just covers the basics, so I won't explain a lot about this source code. But if that makes you go, "Aw, he's skipping the good part," check out our companion video entitled Botnet Source Code for Overachievers. It's a screen capture video where I explain the source code and configuration in depth. For now, I'll just move through some highlights. One thing any net admin should understand about bot code is how modular it is. See these files? Each one is a snippet of code containing a different exploit. A bot herder can make his bot client scan for one vulnerability, or 5, or 10, simply by moving modules in and out. Modules let him change the behavior of his bot code to baffle law enforcement. No wonder career cybercriminals like bots. Bot source code always includes a configuration file. To customize this RxBot example, Botmaster Spike would edit this config file called configs.h so his bots work properly with his command center. For instance, Spike's bot is now configured to connect to an IRC server with the IP address 192.168.39.127 using the port 54321 and the server password killer. It's also configured to join an IRC chat channel called EvilBot. You'll see later why this matters. When Spike is done choosing all his configuration settings, he must compile the source code. That's what makes it executable. Visual Studio makes this step easy. Just click Build, Build rbot.exe. The compiler chugs away for a while and eventually outputs a .exe file. This example produced rbot.exe. Voila! Spike now has a malicious bot client he can sneak onto victim machines. Next, he would put this .exe file through two more processes, packing and crypting. If you're interested in these processes, check out the supplemental Overachievers video I mentioned. Spike now has his evil bot client, but whoop-dee-freaking-do. If it successfully infects someone, it can't tell Spike, and it can't receive his commands. Spike needs to build a command and control server. Coming up. control his army of bots, a bot herder needs a command and control server, or a CNC. Because he's using RxBot, Spike needs an IRC server. Most botnets run on IRC, but you'll rarely find them on public IRC servers anymore. Today, bot herders hide by setting up private servers. Spike installs his IRC server on a remote victim machine. That way, if someone tracks down his command center, he can lose it and live to herd another day. In the botnet community, the IRC server of choice is Unreal IRCD, or Unreal. Unreal works on Windows and Linux. It's lightweight, relatively easy to configure, and open source. The bot Underground has created tons of mods, versions of Unreal that go beyond what average IRC servers do. Unreal mods enhance security for guys like Spike. He can make all his bots invisible to everyone but himself. He can support high numbers of connected users from one server. The bot Underground is a dog-eat-dog world, and Spike will need every trick to survive. For Spike's botnet to work, some of Unreal's settings must match the settings he configured in his bot client earlier. Remember, his bot client is trying to connect to a certain IP address and port using a certain password. So his IRC server had better be that IP address, listen on that port, and accept that password, or Spike's bots can't connect. Once Spike configures his Unreal server, he just starts it up so that it accepts connections. To prove it's working, let's connect to it using a normal IRC client. Spike can connect to his remote server using any IRC client he wants. He's using Windows, so he chooses MIRC. A lot of bot herders run MIRC with an add-on called NoNameScript, which adds cool customizations. To connect to his Unreal IRC server, Spike enters his server's IP address in MIRC, along with the server's port number and password. He also needs to assign himself an IRC nickname. Then it's just press and go. Voila! Spike is logged into his IRC command server. IRC uses channels. Channels are like conference rooms that have names. Once you join a channel, you can chat with everyone else in the same virtual room all at once. If everyone can chat at the same time, who's in charge? Well, IRC servers automatically assign operator privileges, or ops, to the first IRC user who joins a new channel. Spike programs all his bots to join a channel called EvilBot. That way, he can issue one command and they'll all receive it. But Spike needs to make sure he's the first one on that channel or he won't have ops. So here's what he does. After Spike logs in, he joins the channel he'll use as his control channel by typing /J followed by the channel name. Spike was the first to join this channel, so he got ops. You can tell because he has the @ symbol next to his nickname. That indicates he's a channel operator. With ops privileges, you have total power over a channel. Some bot herders try to take over channels that belong to rival bot herders, because with ops, they can steal rival bots. So, Spike assigns a password to the channel to keep unwelcome guests out. Of course, his bots must know this password too. He can also run his channel in moderated mode, which means no one can talk here but Spike. Finally, he can set a descriptive topic for the channel. We'll return to that point later. Has Spike progressed towards his goal of worldwide botnet domination? Sure. He's configured and compiled a malicious bot client, configured and started an IRC server with connection settings matching his bot client settings, and he's logged on to his IRC server and gotten ops on an IRC channel he'll use as his command center. Too bad he only has his bot client. That means it's harvest time. Let's recruit his bot army. Like earning your first $1 million, getting the first bot is the hardest. But Spike can use anything in his nasty bag of tricks. Here's why. A bot client is just a small executable file, so a bot master can install his bot code using any exploit known to hacking. He could spam it out attached to emails, or disguise it as a music download on BitTorrent, or spread it in any of a million ways. In fact, many of the Trojans and worms you've heard of are actually bot clients. Each time a bot scanner finds a vulnerable machine, It loads a copy of the bot client to the new victim. As new bots join the network, the bot herder's scanning ability grows, allowing him to find new victims faster. He can gather as many bots as he wants, in some cases coordinating hundreds of thousands of computers. Let's assume that some of Spike's dirty tricks worked, and his bot client has infected at least one victim PC. Now that he has one bot, let's go to Spike's IRC client to see what he sees. Hey, look at that! A new IRC user has joined the evil bot channel. That's Spike's first bot in this network. Notice that it conveniently generates its own nickname. Here's how Spike can control his bot. RX bots pay attention only to commands that have a particular prefix. This is another feature to prevent a rival bot master from stealing Spike's bots. When he configured the bot source code earlier, Spike configured it so his bots will only obey commands that start with a question mark. It's kind of like Simon Says. Remember, when Spike made the bot client, he assigned it a password. To control the bot, he must log in with the same password. Notice that logging in didn't work without the question mark. Spike's one lonely bot could eventually recruit thousands from all over the internet, so here are some commands he can issue to learn about each specific bot. To learn the IP address of a bot victim's PC, Spike uses the netinfo command. To find out more about the bot victim's system, Spike uses the sysinfo command. This command reveals what OS the bot runs, how much hard drive space it has, and more. If you're one of Spike's victims, this is information about your computer. If Spike heard several different kinds of bots, the scan stats command tells him what vulnerabilities this bot knows how to exploit, and shows whether it has successfully exploited any. Since he hasn't started his bot scanning yet, the vulnerabilities show 0 results. With only one bot, Spike's primary goal is to recruit more. This particular RX bot variant comes with a special mass scanning command, which tells each bot to attack random computers using 5 exploits all at once. That's a good way to harvest a lot of bots fast, and Spike can accelerate that even more. Here's how. He can use the RX bot's topic commands feature. Remember, Spike defined a channel topic. RxBot is programmed so that when he defines a topic, he can make the topic a command. The moment a new bot reports to this channel and sees the command, the bot automatically executes it. He's made the topic of this botnet channel the mass scan command, so any bots joining the channel should automatically start scouring the internet for more victims. Want to see? I'll show you how this works, but I don't want to endanger the internet, so I'm limiting this mass scan to the IP range of my test network. Imagine Spike starts his current bot scanning. Okay, there it goes. Now we kick back and wait. Whoa, looks like the bot got its first victim. Now it's uploading the bot client to that new victim. And there's a new recruit joining the channel now. Since the mass scan command is the topic of the channel, the new bot automatically starts scanning for new recruits as well. Things are really heating up now. As Spike gets more bots, each one adds its resources to looking for more victims. The more bots, the faster the recruiting. In short order, one bot has turned into 20 devices on my test network. You can imagine how a determined bot herder on the internet could grow his zombie army almost exponentially. Whenever Spike considers the bot harvesting phase complete, he simply calls off his troops. Now that Spike has a small army of bots under his control, what can he do with it? To see the evil deeds he perpetrates in his attack phase, watch part 2 of our 3-part malware analysis botnet series. Don't miss it because the real fun's about to begin.